All right, good morning, everybody. You guys are going to be learning about dimensional analysis this morning. All right, and what dimensional analysis is, it's a fancy term for the method we use to convert units of measurement. All right, and we do this by using what we call conversion factors. All right, so this is the method in which you guys will learn how to convert units of measurement. And for you guys, since you are learning this in science, you can also use it later on in math or statistics or biology. Specifically, we're going to be using this in chemistry. All right, so the first thing you need to know about dimensional analysis is you actually need to define two terms, right? We're going to define the term equivalent relationship all right, and we're going to define the term conversion factor. Really important vocab words here. All right, and so let's talk about an equivalent relationship first. Equivalent relationships are, as they are, the term suggests, equal, all right, measurements. Right? So equivalent, we're thinking equal. Okay? So if we're thinking about units of time or measurement, let's take a look as an example at measuring time. Okay. If I were to measure time and I wanted equal measurements of time, I could say, for example, that I have, all right, there are 24 hours is equal to the amount of time that passes in a day. I could also say that 60 seconds is equal to 1 minute. I can also say 365 days is equal to 1 year. All right, so all of these are equivalent relationships, right? They're used to denote, there's two different units of measurement here, but they actually equal the same amount of time. So we have equivalent relationships, and now we're going to talk about conversion factors. So conversion factors are just ways to rewrite the relationships we already know. Right, so conversion factors, you can think of them as the fraction form. So if we were to write a conversion factor, all right, and we were to write it for this equivalent relationship, 24 hours is equal to 1 day, the way that we could represent number 1, I'm going to write CF number 1, okay, for conversion factor 1 will be 24 hours divided by 1 day, or, okay, I can write the conversion factor number 2, 1 day is equal to 24 hours. And you guys can see that these are both reciprocals of one another. So these are the conversion factors for the equivalent relationship. 24 hours is equal to 1 day. All right, so just to remind you guys, we're talking about dimensional analysis here, and we're going to be using these equivalent relationships in order to help us convert units of measurement. All right. All right, so here we've got one-step dimensional analysis, and for this example problem, I have how many weeks are in 9.87 times 10 to the third fortnights. Now, in this problem, I'm trying to go ahead and convert fortnights into weeks. That's what I want to figure out. So step 1 of dimensional analysis is that you're going to go ahead and mark up your problem. The way that I like to mark up my problem is I like to look at the units. I like to figure out what I'm going to solve for. In this case, how many weeks are in 9.87 times 10 to the third fortnights? Weeks are the unit that I'm trying to go for. So I would mark that up, and I'd probably put a circle around it and put a question mark because that's what I'm looking for. The next thing I know is that I am trying to solve for what I actually have is what I'm given. I know that I have this number of fortnights. Now, fortnights is a really weird way to tell time, but hey, who are we to judge? So here we go. With one-step dimensional analysis, all right, we're going to go ahead and apply math, all right? We need to first figure out what's the equivalent relationship, all right? So we have weeks, we want to go to fortnights. What's the equivalent relationship that will get me there? Is there a way that I can make weeks equal to fortnights? Right, so here we have weeks is equal to fortnights, and I'm trying to figure that out. And if you were to look and find the equivalent relationship, you would actually see that 2 weeks is equal to 1 fortnight. All right, so step 1 is done. We have marked our problem. We know what we were given, and we know what we're trying to solve. We also went ahead and stated our equivalent relationship. So now we're going to move on to step 2 for solving a one-step dimensional analysis. And so the way that we're going to do step 2 is we're actually going to set it up in a really funky way. All right, so in chemistry, we're a little bit lazy when it comes to writing out problems, and so here's what we've got. We're going to write out all of our fractions now in a new form. So right here, there's a bar, and in math, we know that at the top of a fraction, we have the numerator. At the bottom of a fraction, we have a denominator. And generally, in chemistry, when we're solving dimensional analysis problems, what we're going to do is we're going to draw this horizontal line, and then we're going to draw a vertical line, so this kind of cross method, all right? And what this vertical line represents is it actually represents the multiplication symbol, all right? So every single time you see a vertical line through each of your problems in dimensional analysis, it really just means that you need to multiply, all right? And so here's what we've got. To set it up, all right, this is what we imagine. We have 9.87 times 10 to the third fortnight. So I'm going to go ahead and write that in. 9.87 times 10 to the third. And we're going to not be lazy and write the entire unit, fortnights. All right, and so now I'm just trying to figure out, again, I want to know how many weeks that is. And so I'm going to be solving for weeks. All right, we have this equivalent relationship where I know that 1 fortnight is equal to 2 weeks. And because I already know that I can write these equivalent relationships as a fraction, this new bar right here is exactly where I'm going to put my conversion factor. So I'm going to take what I have and I'm going to multiply it by my conversion factor, which is just my equivalent relationship expressed as a fraction. All right, so here's what we've got. We've got 9.87 times 10 to the third fortnights, and I'm going to rewrite our equivalent relationship, all right, as a conversion factor. So we have 1 fortnight is equal to 2 weeks. All right, and this is my one-step problem. All right, and here's what we've got. Before we even solve this problem, I just want to go ahead and rewrite what this actually means. All right, so I'm going to move it up a little bit so you guys can still see that this right here, right, this is just the chemistry way of organizing your math and a chemistry way of showing your work. What you are actually writing out is this. You know that you're given 9.87 times 10 to the third fortnights. All right. And if you were to write this out in regular math, you would be writing the multiplication sign right there. All right, and then you would actually be writing that same fraction, that conversion factor, 2 weeks, all right, divided by 1 fortnight. Right, so I haven't done anything different. I've just set this up, all right, a little bit differently with this kind of crisscross method. All right, in math, we know that we can multiply fractions. All right, we can multiply fractions by multiplying everything in the numerator and dividing it by everything in the denominator. So if I rewrite this problem, this is what I have. I know that I have 9.87 times 10 to the third fortnights multiplied by 2 weeks, and I'm dividing now by everything on the bottom, which is going to be 1 fortnight. Alright, so take a look at what I just rewrote. I have fortnights times weeks divided by fortnight. I'm going to go ahead and use this example problem to the side. What we know is that, and I'm going to write this aside, alright, because this actually is just a refresher of math, alright. What we know is that if I have anything, let's say 5, divided by itself, alright, is actually going to be equal to 1. So again, we know that 10 to the minus 9 divided by 10 to the minus 9 is just going to equal itself, so it's just 1. Alright, similarly, we know that, let's say, 1, 2, 3, 4 divided by 1, 2, 3, 4 is also still 1. So when we take this principle and we apply it here to our units, a fortnight divided by a fortnight, that's actually just 1. And now we have our unit that is canceled, and what we're left with, ladies and gentlemen, is the unit of weeks, which is actually what we were looking for up here. Alright, so we're left with the unit of weeks. Alright, and all that's left to do is the math. So here we are in step 3 of dimensional analysis. We're going to do the math. You're going to go ahead and multiply all the numbers on the top, everything in the numerator, so 9.87 times 10 to the third, times 2 divided by 1, and this number, after you plug it into your calculator, should give us how many weeks are in 9.87 times 10 to the third fortnights. Alright, so step 3 here, and the final step to figuring out this problem is actually doing the math. And so here we've got our calculator. Alright, and what I'm going to go ahead and put in, I'm going to put in 9.87, and you see this times 10 to the. This times 10 to the in your scientific calculator, alright, you can actually use a specific function. So you're going to press second, and now you're going to hit this button EE. So you're going to see that E. That is the same thing as your times 10 to the, and now we're just going to put in our exponent 3. And we're going to multiply by 2 and divide by 1. And here we've got our answer, 1.974 times 10 to the fourth weeks is equal to 9.87 times 10 to the 3 fortnights. So again, 1.974 times 10 to the fourth power weeks is our answer to this first problem.